Good morning, afternoon, evening. I don't know if you are sleeping or are not sleeping, are asleep. I don't know. But hello, everyone. This is who I am. Okay, brief. My talk is about WireGuard for dummies or gunnies. I don't know what do you want. And it's not technical like Lorenzo, but I think it's okay. This is my gadget for decrypting text. I need it. Okay, put on. Let's start. WireGuard is extremely simple yet and fast modern VPN that utilizes state-of-the-art cryptography and aims to be faster, simpler, leaner, and more useful than IPsec. While avoiding the massive headache, it intends to be considerably more performant than OpenVPN, but already you can read it at WireGuard website. I'm not going to read all. Okay, this is what the creator says about WireGuard. It's not, oh, I need the, okay. It's we can say that it's simple and easy to use. Cryptography is sound, minimal attack surface, high performance, well-defined, and thoroughly considered. Why is simple and easy to use? It's aimed to be the easiest. Easy to configure. I'm very nervous, sorry for my English. And deploy as easy SSH. There is no need to manage connection and present extremely basic and yet powerful interface. It's cryptographically sound because it uses state-of-the-art cryptography. It uses noise protocol framework, curves, CHA-20, Polyblake. It has conservative and reasonable choices about cryptography and reviewed by cryptographers. Okay, it has a minimal attack surface because it's designed with ease of implementation and simplicity in mind. Implemented in very few lines of code, easily auditable for security vulnerabilities, and comprehensively reviewable by single individuals. It's not need a team of people reviewing the code like OpenVPN that has thousands of lines of code to search for vulnerabilities. It has a high performance because it has high-speed cryptography primitives lives inside the Linux kernel. Okay. It's the result of a lengthy and thoroughly considered academic process, resulting in the technical white paper, which defines the protocol and the intense consideration that went into each decision they make to create the WireGuard. Here is, I need from my bag, please. Yes, the one, get. We have an Ethernet frame. This is the 14 header, the payload, and the trailer. Then WireGuard is encapsulated over a TCP/20 and UDP/8, remaining 1,474 bytes. Sorry. Okay. Then we have 16 bytes of WireGuard header in the message data and the same amount of bytes of the trailer to be multiple of 16 bytes. And the resulting is that payload that if we use TCP or UDP inside the tunnel, we have effective payload of 100, 440, or is you using TCP or on UDP, we're using 1,412 bytes. If we are using IPv6, the numbers change a little. We're using a 40 IP header, and it's resulting in a 1,420 bytes. We're encapsulating IPv6 inside. We have a resulting available payload of 1,360 or 103,072 bytes. Okay. MikroTik uses a default MTU, this one, because we can tunnel IPv6 or IPv4, or we can mix transport over IPv6 and tunnel IPv4 or the other. Okay. We are going to put a real-life example of WireGuard packet. Here we have layer 2 header and trailer, okay? You have here IP UDP header of the packet. This is the WireGuard protocol, and that is the encrypted data. We don't know what kind of meat is that. It's encrypted. And maybe this is fragmented data, or maybe lost packet, I don't know, okay? We have two actors. We have the initiator and the responder. In the first stage of the protocol, we had a handshake initiation and a handshake response. Upon it finalized, then the initiator sends a first data packet with data key, and the responder sent data key confirmation. This is aimed to do the three-way handshake of TCP, okay? Because we're using UDP, we don't have confirmation of the handshake end. Then after that, we can exchange data packets in the session. After that, minutes, hours, days, I don't know. We have another key change, okay? And it's starting a new handshake initiation and handshake response. In this case, if the responder has data pending to send to the initiator, it holds the sending till they has a confirmation from the initiator. But if the previous key is still valid, it can send data with the old key. Okay. After that, if the initiator sent with the new key, the responder sent a confirmation with that data or empty. It don't have any data to send to confirm the new key, and the process continues till the end of the days, the world or the European Union, I don't know, but it's still forever. Okay, going to MikroTik is not implemented on ROS 6, it's only on ROS 7 or Unicorn, maybe, okay? Interface change across versions. In the WireGuard menu, we have the configuration. We don't need to install additional packages because it's on the main packet. This is the interface from ROS 7.1. in ROS version 12, they added WireGuard export and reset traffic counters is not in that version here. And on also, they put a private key and preset key on the peer configuration and a client config. And also added the client config is that and the QR code to scan from the phone. Okay. I think I go very quickly. We have site-to-site configuration. For example, Office A to Office B. We have this address to workstations, the address. And we are going to implement a WireGuard VPN. First, we have to create the interface. And on the Office 1, you can MTU of 1420, and the listen port is whatever we want there. It's for my command line. And we get the information after applying. We retrieve the public key we are using in the other side. We had to assign an IPv4 address for the interface. It will be a subnet 24. We're using several peers, or maybe a 30 point to point. On Office B, also we create the interface the same way and get the public key. Assign an IPv4 also, and we have to do the peering. So for adding peer in the Office E, Office B, Office A, Office B, we show the WireGuard interface info in Office B. We get the public key and put on peer and get the IP we assign to the Office B and put in allowed address. And also the Office B subnetwork here, we put in allowed address. Here is in Office A, this allowed address is like access control list, okay, to go through the tunnel. In Office B, we add the peer of the Office A. It's the same process. We show the WireGuard interface info of Office A, get the public key, put the public key, get the WireGuard tunnel IP, and put the subnet because we want to access from this LAN subnet to the other subnet. Okay. In the Office B, this allowed address is a routing table. Okay. Like. Then the other configurations is a roadwarrior configuration. We can use a MikroTik or another router or a mobile or a laptop to connect to my Office A everywhere. We don't need to be in a static place. In this case, this Office A don't have an endpoint information of the roadwarrior. Okay, refers originally to sales agent who spends their workday traveling from one place to another place and don't have a fixed location. In a VPN, roadwarrior is a device that does not have a known public IP and is therefore only capable of starting the VPN. Office A is not capable to start the tunnel to the other devices. Then in the Office A, we have to configure the WireGuard interface, the remote public key, and the allowed address only of the each roadwarrior. Okay. Then, in the case of MikroTik, we do the same process like do on the site-to-site. We create the interface and get the public key, assign an IP address, and add the roadwarrior peer to the office. We only set the public key and allowed address and responder true. This parameter is only the version 15 of Road 7. Okay, not the endpoint address or endpoint port, because WireGuard is roaming compliant. Okay, it's used the last IP and the last port seen on the packet to respond to the other party. Then we add to the office the office to the roadwarrior, the office A information as prior we do. So the information, public key, allowed address, all IPv4 internet, because we are using Office A of our default gateway to access to internet. We assign, this is the real endpoint address and the endpoint port of the Office A. But this is a dynamic IP, is no problem, because if we only need to reach the Office A in the same, either in the first packet. After that, we can exchange information with no problem. If we're using a mobile, we have to download and install the WireGuard app, create a new from scratch, that button. We have to put the information, the public key, during a button, it get the private key and public key. We copy that public key to the keyboard. Obviously, it's not secure, like Mitchell says at the very beginning in the morning. After that, we need to add a peer with the Office information. You have the public key, the endpoint and address and port, and we are using all as a gateway. Okay, we do the save, and here we have the peer information. If we click that button, starts the VPN. Okay. For a laptop, we have to download the WireGuard installer, install of administration, empty channel. It's only starts with a private key and a public key. We need to put the rest of information in the section interface. We have to add the address of the okay, the address of the WireGuard interface. If we are using the DNS server from Office A, and in peer section we have to add the public key, allowed IPs, and endpoint to complete the setup. Once we add that information at Office A, we can show the client configuration, and we can copy that and paste here, and we have all the configuration done. Or scan the QR from the mobile, and we add the peer automatically. Perfect. Then we can create the roadwarrior private key from the MikroTik in Office A. This way we don't need to create first the key pair on the client device, like we do this automatic, or in the mobile, pushing the rollout button. But in that case, the problem is that that information is sticky. If we delete it reappears again, and we have the client's private key in the router of the office A, and it's everyone with access to the router can see the information, and that can impersonate the client's connection and do bad things. Okay, let's talk about MTU. I think I'm going very fast. We have a MTU of 1420, and if we do a ping from the office A to the office B without fragmentation, we have a total MTU of 1,494 bytes, counting the layer 2 header and FCS, but it's only 1,480 bytes of payload. We were lacking, we have 20 bytes of used data. Okay, there is that payload of the UDP counting the WireGuard protocol because it's 32 bytes of the header and the trailer of the WireGuard. Okay? If we are only using IPv4, then we can grow this number to 1,440 bytes. Oh, it's more reasonable to the 1440, no? I think. Yeah, without exceeding the 1500 bytes. It's underlying layer 3 MTU of the Ethernet interface. Then we configure on the, both sides, and then if we repeat the ping, then reply the ping, we have a full layer 2 packet. Okay, we gain 20 bytes. Then it's of a normal Ethernet connection, but our ISP provider gives us a PPPoE connection. We configure on our MikroTik, it gives us 1480 bytes. We know that the maximum MTU for PPPoE connection is 1492 bytes. Okay. MikroTik uses a default. This default number is a maximum because seems to be an extensions. I don't find it anywhere, but it's a number I search and not found because it's that number here. Then we have 1440 because only using IPv4, and we have PPPoE out. We do the same ping, and we get fragmentation here. Okay, because we are exceeding 8 bytes from the maximum layer 2 packet. Okay? Then, if we go from office B to office A, it's worse because we send only one packet, but in the PPPoE server, it's fragmented in 2 packets again. Okay, we get fragmentation also in this direction. Then we are not good with math, and put 1472 for WireGuard MTU, only taking off the 20 of the IP header and the 8 of the UDP. Then get this configuration. If we perform the ping from office A to office B, okay, we get in the first direction, as expected, we get two packets here. But in the response of the ping, we get is even worse than the other case because we are getting another fragment. It's not reassembling the information here because we are sending two packets because we are exceeding the MTU directly, and when it reaches the PPPoE server, it's fragmenting that packet into two packets, one 74 and one 1498 bytes. Okay. WireGuard is not doing MSSS automatically. We have to do it by hand. We have to configure in the manual rules to set the maximum MTU on the TCP. Okay, here we have a trap in the numbers. You see the trap. The presentation is going very fast. I know, I'm very nervous. I speak more quickly. You see the trap in the numbers here? Nope. We never get the maximum size here because we are talking, we are taking in consideration the minimum, the PPPoE payload of 6 of the PPPoE and 2 of the PP, and not the 20 that MikroTik is putting on that interface. Then even the fragmentation is worse because we're thinking of 1492 bytes of packet, but really we are sending 1480 bytes over PPPoE. Okay, then the numbers is really worse than the we are calculating here. Okay, this is the we can adjust that. Okay, we can set here the 1492 in the server and the client, and the numbers get a little better here. Okay, the fragmentation is also doing, but then we reach the total packet size here. Okay. Then it's over. I'm so fast, like WireGuard is very fast, like me, speaking a lot.
Thank you so much.
Any questions?
Wow.
Hello. Do you think it's a good practice to reduce the maximum segment size for TCP connection in the forward chain in the WireGuard?
If I think yes, but we have to take in mind that we can change the numbers in any moment, and then we have to recalculate all the MTU size and the other numbers because WireGuard is not doing for us. Okay, but perhaps it's getting a very more pilot. And I do test with a 2216 too between them over a PPPoE server in Spain without changing anything. Okay, and I'm getting over 1 gigabit, 900 bytes of transfer between endpoints. If I use the MTU, we can get even more transfer.
Other question?
Yeah.
I'm not sure it's actually a question, but when you explain WireGuard for dummies, you should not forget to explain the role of allowed addresses for choice of peer. Because the WireGuard interface actually acts as a small router inside the router, and when you give it a packet to deliver, it goes through the peer list and looks at the allowed addresses and uses the items on this list to choose the right peer to deliver the packet to. I think it should be in the presentation as well.
Yeah, I I say that in the initiator side is allowed address is acting as access control list when the router has a data packet to send to a peer, it looks into the access list. The allowed address, it match with one peer, then encrypt the data and send. And in the other side is like a mini router inside that is routing like a IPC protocol is doing. We don't have any, well, yes, we can put an router in the IP routers through the IP of WireGuard, but it is default address, and so we put one default address, but it is looking into that mini router to route the traffic, yes.
Next question.
Okay, I again have only a comment. I replaced some VPNs by WireGuard. I really like it very much, but it should be mentioned it's a layer 3 VPN, not a
Yes.
layer 2, which was my big mistake in the beginning. So you can't put the WireGuard interface to a bridge, for instance. And the second one, which I like much more and like to say is that WireGuard is not only point-to-point VPN, but it can act as a point-to-multipoint VPN. So you only define more peers and you have a VPN among all the peers at once. And this should be mentioned, I think, because it makes some things very much easier than anything else.
Okay, yes, it's a layer 3 channel, I forgot to mention. I'm getting very nervous when I speak in public. I don't know why, but, and yes, it's only layer 3. If we want to, a layer 2, we got to put over AOAP or VXLAN to get this layer 2 and get the MTU is lower again. It's also one thing I forgot to say early is that we can get so many interfaces as we want, but only we have one IP, one address in each WireGuard interface. If we put several IPs, in my experience, it gets crazy and not route the packets correctly, okay, through the clients. Then we can set a site-to-site interface and a site-to-multipoint interface for different peers we have there. I forgot to say, okay, this one. It's good to have questions because I remember things I forgot. Here, in the responder part, no, I passed here. Okay. this configure is, we put the information we need there, and site-to-site is more easy to see. Appear, okay, here. Okay, we put that on the peer, we add that information is correct, is all we need in the both sides, but the tunnel don't get up. Okay, that's running up. You can go crazy, reading, changing everything, redoing all the stuff, but we have to. I test in several versions, and it's, I don't know when it changed it here in the peer. Sorry. Que this is WireGuard, not public key. Here we have to set up a persistent keep alive. Once we put a persistent keep alive, the tunnel running up immediately. And don't stop. It's not make any sense because it is for maintaining the UDP hole in the router, but it is, in WireGuard website it says that once you configure the parameters, it starts immediately. Okay, we don't go to the interfaces start. In MikroTik also, but we need to put a persistent keep alive. Since they put that parameter, we need to set up. Yeah. If we are using site-to-site, yes. If this is Office, there is the server, we don't need to put because the other side is going to start the tunnel. Okay, the other side needs the multi-point, the MikroTik is the other side, needs to put that parameter. In mobile is not that parameter, and in laptop is not that parameter, only on MikroTik.
Any other?
I was just curious on views with WireGuard running on multi-one environments, because my experience wasn't that great. I had to introduce some routing rules in order to clarify how WireGuard should route traffic through towards multiple peers.
I don't understand anything. Yes, I understand multi-point. Yes, it's understand.
So I was just curious on views with regards to WireGuard when exposed to a multi-WAN setup. So when you have multiple WANs, and say for instance one goes down,
Yeah.
how does, if there's any other way other than introducing some routing rules, if there's any other way to teach WireGuard to go the correct way?
I think I understand your question. Okay, I want to answer. It's not, we start again the handshake and finally we understand each other. If we have multi-one, obviously WireGuard only can run on one, and we have to set up a manual to return the packet from the same one. And if we want to use several ones for set up the tunnel, we have to do 2 connections and set up over another protocol to bind, like binding, to join the 2 interfaces. Is that the question you?
Even with additional mangling rules, it was still flaky until proper routing rules have been actually deployed or introduced. It wasn't performing correctly when WAN failover occurred.
Yeah.
Or when switching WANs.
Not binding WireGuard interface because that sequence of packet, that data packet is not ¿cómo sería? Assured, in the same order in the two directions, and only use one with the mangle and not binding interfaces. Yeah.
It is behind a nut.
Yeah. Yeah, yeah. Thank you to you.
This is the beautiful part of live.
Yeah.
Any other questions? Yes, we have one more.
Hello.
Hello.
You had a slide with a QR code in it. Is that to make it easier for client setup? I think there's a slide with some QR codes at the beginning. Yeah.
If you have QR code for the client side.
I'm out. What for the client side? The code in the here.
QR code. Yeah, this one. You mean this one? Yeah. Yes, the client just scan with the client this QR code and set up. That's it. Oh, you have to protect it, of course. Yeah. If you will expose the QR code, anyone can connect, I think. I'm right.
Yeah.
Other questions? Okay. Thank you very much for
To you.
the interesting
Thank you to
presentation.